Morning everybody and welcome to today's maths lesson. So today we're going to explore ordering and comparing fractions that are less than a whole, so not an improper fraction or a mixed number, a fraction that is less than a whole. And this skill is quite useful for when it comes to questions such as the one on the board. So you can see my cake. I want to share it with Mrs. and Woods. One person is going to get 2/3 of the cake and one person is going to get 5/6. And simply, would you rather have 2/3 or 5/6 of the cake? Now, we can't work it out just yet because in order to order and compare the fractions, the denominators need to be the same. So we're going to have to use our equivalent fraction knowledge and some new calculations today to put our fractions into the same denominators to allow us to order and compare them. But first, to do that, we're going to just have a look using bar models. Now, we've done bar models lots, you've seen them lots of times, so we're just going to explore how to order and compare fractions looking at bar models first. So, as you can see on the board, I've got another would you rather have question. So this time it is would you rather have 5/8 or 3/4? Now, what I'm going to do is I'm going to draw the bars. So I've got my bar here, which has been split into 8, and I've coloured 5 chunks of it because I've got 5/8. And then I've got my bar here, which is the exact same length, has been cut in to 4 equal parts, and 3 of them have been coloured in to help me try and compare the fractions. Now, you'll know from last week for doing equivalent fractions that in order to make them equivalent, the bar models and the parts that are coloured in have to be to the same line if they're equivalent. So for now, we can see that 5/8 is smaller than 3/4 because 5/8 goes to here and 3/4 goes to here. So if that was me, I would want 3/4 of that cake because there's more of the bar coloured in, which means I'm going to get a bigger chunk of the bar. Okay? Let's have a look at this one. So if I look at my pink bar, I've got 1, 2, 3, 4, 5, 6 chunks, and I've got 5 of them coloured in. So I've got 5/6, and here I've got my bar that's been split into 3, and 2 of them are coloured in yellow. So this time I'm going to compare 2/3 or 5/6. Now, I can see by looking on the board at the bar models that, let's just colour out these lines here, 5/6 and 2/3. 2/3 would be equal to here, which would be 4/6. I've got a whole other chunk here, and 5/6 goes out to here. So I can see that 5/6 is the bar that's coloured in more. So if this was a piece of cake, I would want 5/6 of the cake rather than 2/3 of the cake because I would get more cake. Okay, so let's have a look at another question. So I've got finished the model to show 2/5 and 5/20, and then I'm going to compare them to see which one I prefer. Now my 5/20 are coloured in, and on the other side I'm going to colour in what's worth 2/5. Okay, so 2/5 is the same as 8/20, and we know that from doing our equivalent fractions because 5 times 4 equals 20 and 2 times 4 equals 8. So I'm going to colour in 8 chunks here. So now I've got 2/5 and I've got 5/20. Now if that was me and that was a chocolate bar, I would definitely want the 2/5 size of the chocolate bar because I'd be getting 8 chunks, and on the blue side of the chocolate bar I'd only be getting 5. So 2/5 is bigger than 5/20. Let's have a look at another example. So true or false? I've got 4/7 is greater than 4/9. Let's try. My first bar is in 7, I'm going to colour them in. My second bar is in 9. I'm going to colour 4 bits in. Now, let's have a look. 4/7 and 4/9. Now, I'm sure you'll agree with me that more of the bar is coloured in 4/7 than there is in 4/9, because we have, to make them equal, we would have a blank square here. So 4/7 it is true. 4/7 is greater than 4/9. Now, what I would like you to do is to stop here, stop the video, go into the lesson and do the do one questions. The do one questions are just like the ones that we've done, where you're going to use the bar models to colour in the chunks and compare the models to see which one you would rather have, to order and compare the fractions. So stop here, go into your lesson and do the do one questions. When you're finished, come back and we'll move on to the do two, and I'm going to show you the method for ordering and comparing fractions without needing a bar. Okay, so I'm sure you'll agree with me, using the bar models is great. They're very visual, but if you don't draw the bar models correctly, you can't compare the fractions. So what I'm going to do now is I'm going to show you a method where we change all the fractions so they have the same denominator into equivalent fractions, so we can order and compare them. So if we look at 2/12 and 1/4. Now, what we need to be able to compare them is for the denominator to be the same number. Okay, so at the minute we have two different denominators. We have 12ths and we have quarters, and we want them to be into the same denominator so we can compare them. Because if they have the same denominator, it means the bar is in equal chunks and we'll be able to compare them. Now here, I've written down the method. So it says write the multiples of each denominator. So we've got 12 and 4. I'm going to do the first 5 multiples and see if I can get an answer. Find the lowest common multiple. So I'm going to do 12. So I've written down the first 5 multiples of each denominator. I've got the first 5 multiples of 12 and the first 5 multiples of 4. So I've done step 1. Step 2 says find the lowest common multiple. Now we've done this before. So find the lowest number that is in both sets of multiples. And if you look, you'll see this time that the lowest common multiple is 12. So now I know that I'm going to convert each fraction into 12ths. I might have to find an equivalent fraction for some of them. 2/12 is already in 12ths, so I know that that's going to stay as 2/12. But I'm going to have to make a quarter into an equivalent fraction to change the denominator into 12. So 4 times 1, 2, 3 is 12. And we know from looking at our equivalent fractions, whatever we do to the denominator, we must do to the numerator. So 1 times 3 is 3. So now I have 2/12 and 3/12, and you can quite clearly see that 3/12 is bigger than 2/12. So if I was looking at the fractions 2/12 and 1/4, 1/4 would be the chunk that I want. That's the one that is greater than. I'll even put the little greater than symbol in. Let's try another one. So let's do 1/3 and 3/6. So just like before, I'm going to write down the first 18, 24, 5 multiples. I'm going to have to find the lowest common multiple, and if I can compare them, I can see that 6 is the lowest common multiple. So I'm going to need to change them both into 6ths to be able to compare them. So 1/3 needs to move find an equivalent fraction that is in 6ths. We know that to find 3 times 2 is 6, so I'm going to do the numerator times 2. 1 times 2 is 2, so I've got 2/6. 3/6 is already in 6ths, so I don't need to find the equivalent fraction. And I can see that I've now got 2/6 or 3/6. 3/6 is the biggest fraction because 3 is bigger than 2. So 3/6 would be the fraction that I want. So this one is greater than. 1/3 is less than 3/6. See if you can now go and do the one for 9/24 and 3/8. Have a go on a piece of paper, come back, and I'll go through the answers. Okay, hopefully you had time to have a go. So I started to write the multiples of each denominator. I did the first 3 this time because I could see straight away what the lowest common multiple is. And 24 is going to be the lowest common multiple, the number that appears in both sets of multiples, the smallest one. So I'm going to change both fractions into 24ths. The first fraction is already in 24ths, so I can leave it as 9/24ths. And we're going to have to change 3/8 to find the equivalent fraction of 24ths. I can see that 3 times 8 is 24. I'm going to do the same to the numerator, so 3 times 3, which is 9. So now I've got 9/24ths and 9/24ths, and I'm sure you'll agree with me that they are both the same fraction because 9 is the same as 9. So these two are going to be equal to. Lovely, let's go on to the next slide and have another go. Okay, so let's do 3/5 or 4/20ths together, and then you can have a go at the other 2 questions. So I've written out my multiples of each number. I've got my 5s and my 20ths, and now I can look for my lowest common multiple. So I've got 20 and 20, so I'm going to convert both fractions into 20ths. 5 times 4 is 20, and 3 times 4 is 12, so I've got 12 20ths. 4 20ths is already in 20ths, so I don't need to change it. So I've got, would you rather have 12 20ths or 4 20ths? And I'm sure you'll agree with me that I would rather have 12 20ths, so in that fraction I want 3/5. Go and do 2/3 and 8/12 and 5/8 or 3/6 now, and then come back for the answers. So I put the answers on the board for you. 2/3 and 8/12 was equal to, because they both equaled 8/12. And for the last one, I'd rather have 5/8 because 5/8 into 24ths is 15/24, and 3/6 into 24ths is 12/24, and I would rather have 15 chunks. If you're not sure and you've been getting it wrong, make sure you pause, go back, try again, and see if you can work out where you've been going wrong. Remember, the method is here in the yellow box to help you. Okay, I don't have a lot of time left, but hopefully enough time to show you this question, and then you'll be able to get on with the do 2 questions. So it says order these fractions into ascending order. Now remember, ascending order means smallest to greatest, descending order down means biggest to smallest. So we're going to have to do the exact same thing again. We're going to have to change all of these fractions into equivalent fractions so they all have the same denominator. Now I'm going to pause the video to do that, or I'm going to run out of time. So I've written down each multiple, so I've got my multiples of 2, my multiples of 8, my multiples of 4, and my multiples of 12. And now I can find the lowest common multiple, which is 24. So I'm going to have to change all of these fractions into 24ths. Again, I'm going to pause and bring it back. So now I have them all into 24ths, I can put them in ascending order, starting with 4 24ths, because that's the smallest one. 12ths, oh dear, 24ths, then I'll have 6 24ths, 12 24ths, and 21 24ths. And now I've got them in ascending order as 24ths, I can work out what order they would have been in their original form. So this would have been 2 12ths, then we would have had 1/4, then we would have had 1/2, and then we would have had 7/8, and there they are in ascending order. I've run out of time in the video because I only get 15 minutes, but you've got enough there and all the methods to help you go and do the do 2 questions. Go and have a go, and I'm looking forward to seeing how you get on with it.